This is another episode of Christopher Reads the Help Files. This is Getting Started, Drawing, Feature, and Command Settings. Topics in the section: about Autodesk Civil 3D settings. Settings in Autodesk Civil 3D control many preset values, such as drawing unit, scale, and coordinate system. To specify ambient settings, to specify feature level settings, to specify command level settings. About units and zone settings. Using the Units and Zone tab of the Drawing Settings dialog box, you can select linear and angular units, a coordinate system, and scale for the drawing. To specify units and zone settings, about transformation settings, using the Transformation tab of the Drawing Settings dialog box, you can relate the local northing and local easting coordinates of your drawing to the grid northing and grid easting coordinates for the current zone. To specify transformation settings, to specify object layer settings, to specify abbreviation settings. Settings in Autodesk Civil 3D control many preset values, such as drawing unit, scale, and coordinate system. Autodesk Civil 3D has drawing, feature, and command settings. All three levels of settings in Autodesk Civil 3D are saved with the drawing, and they can be saved to a drawing template. Drawing settings establish values for the whole drawing. If you are creating a drawing template, ensure that these are set correctly. All commands use the drawing settings unless there is a specific override at the feature or command level. Feature settings control behavior for a particular feature, such as parcels or grading. Command settings apply to individual commands within a feature, such as create parcel by layout command within the parcels feature. You modify each level of settings at a different location in the settings tree as shown in the following illustration. There are two types of drawing level settings: drawing wide settings, which include units and zone, transformation settings, abbreviations, and object layers. Ambient settings, which affect a variety of Autodesk Civil 3D behaviors. You can change ambient settings at the drawing level, and you can also override ambient setting values at either the object level or the command level. You access drawing level settings by right-clicking on the drawing name in the settings tree and clicking Edit Drawing Settings. At the drawing level, the Edit Settings dialog box contains only the ambient settings for the drawing. The following summarizes the controls in the Edit Settings dialog box. Use the plus or minus boxes to display or hide the settings in the category. Use the value column to specify a value for a setting. The column override indicates that the default value has been changed for the setting. The child override column indicates whether the setting has been overridden at a lower level in the settings tree. Use the lock column to control whether a setting can be changed at a lower level in the settings tree. Object feature level settings. Use the object collection level in the settings tree to control all of the settings that pertain to the object type. Change the object settings at this level in the tree and specify overrides for the drawing ambient settings. Access the object or feature level settings by right-clicking on the object collection in the settings tree and clicking Edit Feature Settings. At the object level, this dialog box also contains object-specific settings such as default styles. Command level settings. Use the commands collection level in the settings tree to override both the object level settings and drawing ambient settings on a command-by-command basis. You can also specify command-specific settings. Access the command level settings by expanding the commands collection for an object type in the settings tree, right-clicking the command and clicking Edit Command Settings. At the command level, this dialog box also contains command-specific settings such as the parcels and alignment settings that are used by the Create Site command. Inheriting and overriding styles. Each lower level object in the settings hierarchy can either inherit or override settings in the level above it. The following illustration shows an override set for area units in the parcels feature level. The arrow in the child override column of the drawing settings dialog box, the upper dialog box, indicates that an override has been set at a lower level. The check mark in the override column in the Edit Feature Settings parcel dialog box, lower dialog box, indicates that the value set in this dialog box overrides the settings at a higher level. At the drawing level, you can cancel a child override by clicking on the arrow icon in the child override column. This causes the arrow icon to appear as follows. You can prevent overrides by locking a setting. To specify ambient settings. Using the ambient settings of the Settings tab of the Drawing Settings dialog box, you can specify default, ambient, background settings for a variety of features, including some that affect units of measurement. These settings control parameters such as angle, area, direction, elevation, and so on. There are also settings that affect the event viewer, tooltips, and how curve returns are created for intersections. In Toolspace, on the Settings tab, right-click the drawing name at the top of the collection and click Edit Drawing Settings. In the Drawing Settings dialog box, click the Ambient Settings tab. In the Property column, select a parameter in one of the categories. As you select a parameter, the description in the lower part of the dialog box reflects the selection. Change the setting in the Value column. Click OK. To specify feature level settings, specify settings for an object type. In Toolspace, on the Settings tab, right-click the object collection and click Edit Feature Settings. 2. To change an object's specific setting, do the following in the Edit Settings dialog box. Expand the category that contains the setting. Click in the Cell Value column. Enter the value or select a value from the list. To override a drawing ambient setting, do the following. Expand the category that contains the setting. Click in the cell in the Value column. Enter the value or select a value from the list. After you change the value, the checkbox in the override column is automatically selected, indicating that the drawing ambient setting is overridden. Click OK. To specify command level settings, specify settings for a specific command. In Toolspace, on the Settings tab, expand the commands collection that contains the command whose settings you want to edit. Right-click the command name and click Edit Command Settings. To change a command-specific setting, do the following in Edit Settings dialog box. Expand the category that contains the setting. Click the cell in the Value column, enter the value or select a value from the list. To override an object-specific setting, including drawing ambient settings, do the following. Expand the category that contains the setting. Click in the Cell Value column, enter the value or select a value from the list. After you change the value, the checkbox in the Override column is automatically selected, indicating that an object level setting is overridden. Click OK. About Units and Zone Settings. Using the Units and Zone tab of the Drawing Settings dialog box, you can enter linear and angular units, a coordinate system, and scale for the drawing. Coordinate systems. Coordinates in Autodesk Civil 3D are expressed using northings and eastings. The Autodesk Civil 3D coordinate system is always relative to the AutoCAD world system. Nothing is equivalent to AutoCAD Y, or northing is equivalent to AutoCAD Y, and easting is equivalent to AutoCAD X. Autodesk Civil 3D object data is always presented in AutoCAD World Coordinate System coordinates. For example, the alignment data in the Alignments Entities vista in the Panorama window is listed in world coordinates. In addition, the Autodesk Civil 3D transparent commands are based on the AutoCAD World Coordinate System. However, when you create an object and have an AutoCAD User Coordinate System defined, the UCS is honored when you specify locations, which means that an intersection point or coordinates is interpretive relative to the UCS. Note, if you share a survey database that references a user-defined coordinate system, you must make the user-defined coordinate system available to all users of the survey database. Autodesk Civil 3D objects are not aligned with the UCS. For example, labels can be oriented relative either to the current view, the world coordinate system, or the labeled object, depending on the orientation reference setting, but they cannot be oriented to the UCS. Similarly, objects such as profiles, sections, and tables cannot be oriented to the current UCS. For more information about AutoCAD World Coordinates and AutoCAD User Coordinate Systems, see the AutoCAD Help. To specify units and zone settings. In Toolspace, on the Settings tab, right-click the drawing name at the top of the collection and click Edit Drawing Settings. In the Drawing Settings dialog box, click the Units and Zone tab. Under Drawing Units, select either feet or meters. Under Angular Units, select an angle format. Specify one of the following for imperial to metric conversion. International foot, 1 foot equals 0.3048 meters, or US survey foot, 39.37 inches per meter. Select the scale objects inserted from other drawings. Checkbox to scale objects inserted from another drawing to match drawing units in the current drawing. Select the Set AutoCAD Variables to Match checkbox to synchronize AutoCAD settings with Autodesk Civil 3D settings. If there are no equivalent AutoCAD settings, a message is displayed asking if you want to match as closely as possible. The AutoCAD settings that are synchronized to the Autodesk Civil 3D settings include the A units, dim A unit, ins units, and measurement AutoCAD system variables. Under Scale, select the intended plot scale in imperial or metric units. Under Custom Scale, select the plotted size of the various annotation-related components, such as label text, and band heights. If you change the scale, all annotation objects adjust accordingly. Under Zone, select a category from the Categories list. Categories include lat-longs, US states, and so on. When you select a category, the available coordinate systems list displays and all the defined zones in that category. If you know the coordinate system code for a zone, you can enter it in the CS code text box and click OK to select the zone. Click OK. About Transformation Settings. Using the Transformation tab of the Drawing Settings dialog box, you can relate the local northing and local easting coordinates of your drawing to the grid northing and grid easting coordinates for the current zone. The zone transformation settings do the following. Relate local coordinates to grid coordinates by transforming distances measured on the Earth, or GOID, to distances on an ellipsoid. Relate distances on the ellipsoid to the flat plane projection of the current zone's grid coordinate system. These transformations are accomplished through the use of scaling factors. First, a sea-level scale factor is applied to the local values measured on the GOID, and then a grid scale factor is applied, which relates the ellipsoid values to the grid projection. The scaling factors can be defined in two ways. The sea-level scale factors relates the distances on the GOID to the distances on the ellipsoid. The grid scale factor relates the distances on the ellipsoid to the distances on the grid projection. You must also specify reference points in establishing transformation settings. These reference points are the 2 points that tie the local and grid coordinates together. The reference points can be defined in two ways: by the grid and local coordinates of 2 known reference points in your drawing, by the grid and local coordinates of 1 point and a known rotation to grid north. To specify transformation settings. In Toolspace, on the Settings tab, right-click the drawing name at the top of the collection and click Edit Drawing Settings. In the Drawing Settings dialog box, click the Transformation tab. Important, you must specify the coordinate system on the Units and Zone tab before you can specify settings on the Transformation tab. Select the Apply Transform Settings checkbox to activate all the controls in the dialog box. Enter values as specified in steps 4 through 10. If you clear this checkbox, then controls in the dialog box are disabled and the AutoCAD X and Y coordinates match the coordinates in the specified zone. Select Apply Sea-Level Factor. If you know the combined scale factor, then you can clear the Apply Sea-Level Scale Factor checkbox. Select User Defined as the grid scale factor and enter a combined scale factor in the grid scale factor box. The combined scale factor is the combination of the scale factor for the converting local to sea level and the scale factor for converting sea level to grid. Enter a default elevation, such as the average elevation of your project site from sea level. Optionally, change the spheroid radius, which is the radius of a mathematical figure close to the shape of the Earth at sea level, approximately 6,370 kilometers. The value shown in this box is initially derived from the current zone's ellipsoid and can be changed if local observations differ. In most cases, the default value shown is the accepted value. For the grid scale factor, select a method for computation. Specify the reference point values. The reference point could be a benchmark that was used in the survey. It can be any point for which you know both the local coordinates and the grid coordinates. To specify the reference point values, do one of the following. Click the Select Point button and then select a point in the drawing, or use transparent commands. Enter a point number, enter the point's grid northing and grid easting values. To define the rotation angle for the transformation, do one of the following. Click the Select Point button and select a point in the drawing, enter a point number, enter the point's grid northing and grid easting values. Specify the grid rotation value, click OK. To specify object layer settings, in Toolspace, on the Settings tab, right-click on the drawing name at the top of the collection and click Edit Drawing Settings. In the Drawing Settings dialog box, click the Object Layers tab. For each object type, click in the Layer column to display the Layer Selection dialog box. In the Select Layer dialog box, select the layer for that object type and click OK. To add a modifier to the layer name, select the prefix or suffix in the modifier column and then enter the text string for the modifier in the value column. To include the object name in the layer prefix or suffix, enter an asterisk in the value column. Click OK. To specify abbreviation settings, use the Abbreviations tab of the Drawing Settings dialog box to change the abbreviations used for the labels. The Abbreviations tab controls various default abbreviations used in the drawing, labels, and reports. For example, the default abbreviation for spiral tangent intersect is TS, meaning that any spiral tangent intersections in a drawing are labeled TS. If you need spiral tangent intersection labels to be more detailed or different, you can change the abbreviation by clicking in the value column and changing the TS value. In the Alignment Geometry Point Entity Data section, the values also contain format strings that describe entity properties that will display in the label. For more information, see about property field modifiers. In Toolspace, on the Settings tab, right-click on the drawing name at the top of the collection and click Edit Drawing Settings. In the Drawing Settings dialog box, click the Abbreviations tab. Specify the abbreviations for the properties by modifying the entries in the value column. For individual abbreviation definitions, see the glossary. Click OK. And so this concludes the episode of Christopher Reads the Help File, Getting Started, Drawing, Feature, and Command Settings.